a perfect square.
This call is now taking notes.
So
This call is now being recorded.
such numbers has to be simplified further. But then when you leave an answer as something like this, maybe root 8, it is wrong. You're done solving and then you're saying that your answer is the square root of 8. So this is wrong because the square root of 8 can still be simplified further. When you simplify the square root of 8 further, you are supposed to have had 4 times 2. So you can see the perfect number, the perfect square within it, which is 4. Then separating this would be square root of 4 times square root of 2. Square root of 4 is 2 times square root of 2, and then you have 2 root 2 as the answer. So this is just a quick revision of the basic simplification, what to do. Now we'll proceed with the multiplication when we say that when you have two sorts multiplying themselves, maybe we have 5 root 3 multiplying 6 root 6 root 6, for instance. So 5 root 3 multiplying 6 root 6. We said that these ones at the back multiplies themselves. This 5 and this 6 now can multiply themselves, the ones outside. While for the roots, it is these ones that has roots that you can multiply as well. So if you have to multiply this, you have to say 5 times 6. That's the ones at the back, the multipliers there. The 5 is outside root 3, the 6 is outside root 3 as well. So if you have to multiply them, it is the 5 outside that can multiply the 6 outside at the other side. Then, when you're dealing with the roots, those of them that have roots, you can then multiply them together and say that this is root 3 times root 6, like this. Then 5 times 6 is 30. 5 times 6 is 30. And then root 3 times root 6 is root 18. So 5 times 6 is 30. That is the multipliers multiplying themselves. Then the roots multiplying the other roots. So root 3 times root 6 gives root 18. But then if you have to stop here, this would be wrong. You could only have the answers that you must have accumulated from the steps you took before this particular point. The reason why you can't have the full answer is because root 18 is still simplificable, something you can still simplify further than it is there. So that root 18 can be broken down to be, we already know that this is 30 times 18, that would be 9 times 2. If you separate this, you should have 30 times root 9 times root 2. Then root 9 obviously is 3. So 30 times 3 times, we can't break down root 2 further than it is, so it still remains root 2. And 30 times 3 is 90 times root 2, that is 90 root 2. So this is the result we get when we multiply this. Now, for the sake of a question someone asked the other time, or I can't recall if it was in the class or not, but then it seemed like most of the examples we treated, when we multiplied them, we always had roots in our answer, just like this one now. We're having 90 roots 2 as the answer. So it is not compulsory that anytime you multiply sorts that a root must still be in the answer. It depends on what you're working on. There are times that when you multiply, the whole root vanishes, everything vanishes, and you simply don't have any root there anymore. It's such an example of such situation could be probably you have to multiply something like let's say look at another example here. Let's say we have to multiply something like 10 root 5 times root 5, for instance. So we have to multiply something like 10 root 5 times root 5. Now, you had 10 at the back behind the root in the first one, but there is no number at the back of the root 5 at the second one. But definitely, we already know that there should be a 1 there since there is no number. So remember that the 10 cannot multiply the roots. The 10 is outside. It can only multiply another number that is outside the root. So that's 10 root 5 there. Multiplying this other one, you can just simply assume that there's a 1 outside the root of the other 5. And then you can say 10 times that one is still 10. Then times root 5 times root 5. That's root 5 times root 5. So the both of them can actually multiply themselves because they're carrying roots. So this would be 10 times is root 5 times root 5, that is root 25. And of course, we all know the square root of 25 to be 5. This becomes 10 times square root of 25 is 5. And the final result here would be 50. So you can see that it is not all the time that when you multiply, if you just suppose between these two, now look at the answer we got at the top and this other answer. So it is not all the time when you multiply, you still have roots in your final answer. It all depends on the kind of question you're working on. So if coincidentally you're doing questions, you're solving questions that only give a root at the end of your answer, it doesn't make it suppose that a root must be there. You already know the procedure. Work with it. If a root happens to be there and you're sure you solved it correctly, fine. If a root isn't there and yet again you're sure you solved it correctly, that's very good as well. Just like these two cases that we have here. So it's not compulsory that root must be there. Depends on what you're working with. Do you guys understand what I'm saying? What about the elders? The elders, winner. Okay. What about winner? About me, winner. Yes, I saw. I can see that. Winner. What about you, Christine? Do you understand what I said? Okay.
Yes,
Winner
sir.
isn't responsive. Okay. All right. Winner, you're not responsive. What's happening? Lucas, what about you? Lucas. Okay. All right. So basically that's that. Then now we will proceed to, we're looking at the other day, we also looked at expanding brackets, that sorts in brackets. It still has to do with multiplication as well. So you have a bracket like this, call this example 3. So you have sorts in the bracket like this. Let's say this is 2 root 3 minus um, 5 to the power of 2, for instance. 2 root 3 minus 5 to the power of 2. And you're expected to solve this, expand this bracket. So what this means is that you have to write this bracket twice because it's to the power of 2, so you're multiplying it by itself. So this is 2 root 3 minus 5 multiplying the same 2 root 3 minus 5. You see, because it's multiplying itself, that's to the power of 2. So 2 root 3 minus 5 multiplying same 2 root 3 minus 5. Then now that day, I was trying to explain to you that you expand something like this the same way you would have said s minus y multiplying to maybe 2x plus 1 or something. The same way you multiply this, you expand this bracket. It is the same thing you do here. And how do you work with this? You would have to say that s, this first one in the first bracket, will multiply 2s plus 1. Then you also say minus y will still multiply 2s plus 1. So in essence, when you're expanding the brackets, each term in the first bracket has to multiply the second bracket. That is why when we had this s minus y multiplying 2s plus 1, we brought out s first. We said s multiplying that second bracket. Then we also say minus y2 multiplying the second bracket. Then you do the work and see what you get. So it's the same thing you have to do when you are dealing with the same thing you have to do when you're dealing with the sword here, because I think I'll have to use this method because some persons had a little bit of difficulty the other time when I was multiplying it directly. So I thought to myself that when we continue today, I'd prefer to use a something else, another method that I feel might be better for you. So what we're doing here, just like I've explained in the using expressions, this 2 root theory in the first bracket, you will use it to times the second bracket, which is 2 root 3 minus 5. That is the first thing. So 2 root 3 in the first bracket times the second bracket. Then there is minus 5 again. You now say minus 5. We also do the same thing, multiplying the second bracket. So this is how you expand brackets, even when you're dealing with expansion of expressions, or if you come across it in equations. 2 root 3 in the first bracket, multiplying the second bracket. The second number in the first bracket, which is minus 5, also multiplying the second bracket. When you get here, you can now start multiplying. Remember, 2, the ones outside times themselves, while the ones with the root times themselves as well. So here, if we have to multiply this, it is these 2 can only multiply these 2. And this root 3 has to multiply root 3. Then you continue, you go just like that. So now, if we are doing this, we'll have 2 multiplying 2. That's the first one we're multiplying. 2 root 3 times 2 root 3, that would be 4 root 9. Does everybody understand how I got 4 root 9? Golden, what about you? Okay. Lucas. Okay. All right. Okay. Winner. Winner is in the class, but she isn't responsive. Christine, do you understand how we got that 4 root 9? Okay. All right. So that's 33 times 33 gave us 4 root 9. Then 33 now has to multiply 5 because, of course, when you're opening the bracket, what you have outside has to multiply everything in the bracket. Now, 33 times minus 5, that would be minus. Remember that 5 is an outside number, like it does not carry a root. So that 5 can only times that 2 at the back of 33. So 33 times minus 5 should be 10 root 3. 2 root 3 times minus 5, that should be 10 root 3. So we are done multiplying the first bracket. We now move to the second bracket, which is the other side, at the other side. And we have minus 5 times 2 root 3, that is the same minus 10 root 3. because minus 5 times 2 root 3 minus 10 root 3. Then when you're multiplying these parts now you have to multiply this minus 5 also has to multiply this minus 5 now because minus 5 has multiplied 2 root 3 to give us minus 10 root 3. Now that minus 5 has to multiply the last number there, which is minus 5 as well. Most students forget to deal with the signs. You see, when you're multiplying numbers, especially numbers that carry signs, you have to be very careful because now minus 5 has to multiply minus 5. That result should be positive because the minus times the minus gives a positive result. So minus times minus is positive. So when you say minus 5 times minus 5 should be plus 25. So do not forget to multiply with the sign you see. That minus you see before the 5 has to always move with 5. Some students just say it is 5 times 2 root 3. So that's not correct. It is minus 5. Every number has a sign. You are either positive or negative. Just like everybody has a some kind of character. I don't know how to put it, but like all humans has some character. You're either good or you're bad. So it is in the same way, numbers are either positive or negative. So when you're carrying a number, always carry the sign. You are either good or you're bad. There's nothing like I'm not good, I'm not bad, I just the center. And there's nothing like that. You are either good or you're bad. Do you guys understand? Okay. All right. So now back to this. That was how we had plus 25 because we had to move with that minus that is attached to the 5. I'm saying minus 5 times minus 5 to get that result. Now proceeding here, we already know that the square root of 9 is 3. So we already know that. So that's 4 times that's 3, which is the result from the square root of 9. 4 times 3 now gives us 12. 4 times 3 is 12. Now we need to look at this place here. I'll have to use maybe red. We need to look at this place here. The place I circled red. That place I circled red. You see, the sorts there, they are like terms. Remember when we're dealing with addition and subtraction of sort. You see, this is like saying minus 10. If root 3 stands for s, this is like saying minus 10s minus 10s. If root 3 stands for s, that is like saying minus 10s minus 10s. And of course, that would have given us minus 20s. So who will tell us the result here? Minus 10 root 3 minus 10 root 3. What is the result? Minus 10 root 3 minus 10 root 3. Golden.
minus 20 root 3.
Okay, minus 20 root 3. Does everybody agree to that? Minus 20 root 3. Does everyone agree to that? Does everyone okay, just that's just one person. Who else? Does everybody agree to that? Christine, do you agree to that minus 20 root 3? Matilda. Okay, Lucas, I see you. Okay, Christine agrees. Matilda, okay. Everyone agrees to winner. I don't think winner is with her phone. She just came on the class. Okay, so that's minus 20 root 3 there. So here we have minus 20 root 3, then plus 25. Minus 20 root 3, then plus 25. Now there is another like terms. If you see this here, um, 12 and plus 25. Both of them are like terms because they are just whole numbers. They don't carry roots. So 12 plus 25, those are like terms, and we just simply say that 12 plus 25, that would be 37, then minus 20 root 3. We can't simplify root 3 further than it is already. So this is the answer you get. 37 minus 20 root 3. If you do not see it like this, then possibly it must have been written this way. Minus 20 root 3 plus 37. So both of them means the same thing. Okay, so that is for multiplication of surds. Now we shall go to rationalization. Rationalization of surds. What does rationalizing a surd mean? What do you understand? What do you think is meant when they say rationalization of sorts. That is rationalizing sorts. What do you think it means um to rationalize a sort? So let's hear from people. Um Winner, your mic is off now. Are you in the class? Where have you been? Where have you been?
No, I'm not in the car. That's why I'm not able to respond.
Okay. All right, it's okay, but I hope you've been following through what we've done so far.
I'm not following.
All right, no problem. I hope you get up to speed as we continue. We're now rationalization of sorts. So, okay, Golden answered one question before. Um, Ma- Matilda, you've not answered the question today. Matilda, okay, Matilda isn't responsive. Christine,
Yes, sir.
yes. Christine, okay, what do you think is meant by rationalizing a sword? What do you think is meant by the word rationalizing a sword?
Removing the square root.
Okay. To remove a square root from a part in it has to be in a particular way for you before you'd want to remove the square root because you see these answers we had now this answer we had there's a square root there but we didn't bother to rationalize. So what is the condition for rationalization? Christine, it's still up to you. What is the condition for rationalization? How should a sword look like before we decide to rationalize such sword?
Uh, the square root and the denominator.
When the square root is at the denominator. Okay, that's good. Let's hear from someone else. That's correct actually, but let's hear from someone else. Maybe someone else will have a more detailed explanation for us. Lucas, what do you think about this issue here? What is the condition for rationalization? Because we've had several answers that we didn't say anything about rationalizing. And now we suddenly came to a topic rationalizing of sorts. Why does this have to pop up? Why do we have to rationalize sometimes? Lucas, the question is directed to you. Oh, I think they're having network issue. Please, if you guys can hear what I'm saying, if you can hear what I'm saying, can you like um express yourselves? Okay, but then Lucas isn't responsive. You responded, but you're not responsive. I asked you a question. Lucas, can you turn on your mic. Oh, I think Lucas has issues with his network. All right, so we'll just quickly continue. So the condition for rationalizing a sword is when the sword happens to be at the denominator, just like Christine said. When you now have a sword, when you have a fraction and you're now having a sword at the denominator, then you would have to rationalize that sword. And rationalizing that means that you are attempting to remove um, the square root from the denominator. So in essence, it is wrong to leave an answer with a square root at the denominator as at the fraction. It is wrong to leave an answer that way. Swords shouldn't be found at the denominator. If you leave your answer like that, then definitely you wouldn't be scoring the full marks that are supposed to be allocated to that. Look at what I'm trying to say. If you have swords like this, maybe 2 root 3 over 5, this is okay. I think we can actually mark this correct. If you have swords like 3 over root 2, then this is not to the left the way it is. 2 root 3 over 5, that's okay. There is no sword at the denominator. But you see this other fraction, 3 over root 2. So it is irrational. It is irrational. It means that it is not proper. Rationalizing the sword is you attempting to eliminate that root from the bottom and in essence trying to make the sword to be proper. And that process of trying to make the sword to be proper by eliminating the root from the bottom is what you call or you refer to as the rationalization of the swords. So today we'll try to look at some questions on how to rationalize swords, and then we'll see how it goes from there before it gets to your turn where you have to answer questions in the class. Okay, so first question is let's say to rationalize 2 over 3 root 5. Example 1, rationalize 2 over 3 root 5. So there are two ways you can actually rationalize a sword. You can either decide to rationalize by multiplying both the top and the bottom. When you're rationalizing, you have to multiply both the top and the bottom with that root at the bottom. So you're rationalizing by multiplying the numerator, that is the top, and the denominator, that is the bottom. And you have to multiply it with that root at the bottom. The root at the bottom that you're trying to remove, you have to remove that root 5. It is improper for root 5 to be at that denominator. You have to remove it. And removing it is rationalizing we're talking about. So by removing it, you need to say that 2 over 3 root 5 multiplied by root 5 at the top over root 5 at the bottom. So you can see that you're using root 5 to multiply the top. At the same time, you're using root 5 to multiply the bottom. The reason why you're doing that is because it is root 5 that you're trying to eliminate. You're trying to remove that root 5 from the bottom. That is why you multiply the top and the bottom with root 5. So this is just one method. Some teachers might say multiply the top and the bottom with the full bottom. Use the full, what you have at the bottom, 3 root 5. That's what you should use to multiply the top and the bottom. So if you do that still, you still get to the same results. So now let's continue with this. We're multiplying the numerator and the denominator with root 5. We've already written that down. 2 over 3 root 5 times root 5 over root 5. The next step, you have to multiply 2 times root 5. So 2 times root 5 gives you 2 root 5. That is the one at the top. Then over at the denominator, 3 root 5 times root 5. That gives us 3 root 25. So you guys look at this. Do you understand up to this stage that we have now? 3 root 5 over 3 root 25. Do you understand up to that stage? Okay. What about Lucas? What about you? Lucas has not been responsive. Uyo, sir, are you just coming? Yes, yes, yes. I get that your network. I noticed. Uyo, sir,
Sir,
are you just coming, or do you understand
yes,
how we got that result there?
I'm just coming.
Oh, I thought so too, because I'm just seeing your name there. All right, so Wina said she understands. Others said they understand. All right, we also just this is just the first example for rationalization. You get up to speed. Just continue as we go further. Listen as we go further, I meant to say. All right, so we did this and we got 2 times root 5 gave us 3 root 5 over 3 root 5 times 5 times root 5 gave us 3 root 25. Then at that bottom, we have 2 root 5 over 3 root 25. That should be 2 root 5 over, we do know that the square root of 25 is 5. The square root of 25 is 5. Now, 3 times that's 5, which we get from the square root of 25. 3 times that 5 gives us 15. So you can see that this is the result we get, and we no longer have a root at the bottom of the denominator, rather. So this is when you say you have rationalized the actual question. That is, you have made the actual question to make sense. It wasn't making sense while it was still 2 over 3 root 5, because it is improper for a root to be at the denominator. Now, making the question to make sense, making it proper, is the rationalizing there. That is the word rationalizing, making it make sense. And then, like we've said, to do that, we have to multiply the top and the bottom using that root at the bottom you are trying to eliminate. That is what you use to multiply the top and the bottom. Then, of course, you work. If your work is correct, if your multiplication is correct, then you should have the correct answer. When the root is no longer the denominator, that is when you say you've successfully rationalized that question. So let's look at number 2, example 2. Okay, so for example 2, let's say 5 root 6 over 4 root 2. 5 root 6 over 4 root 2. So this is what we are trying to solve here. I think we should add something to this because of, let's let's use um let's use 20 root 6 instead, because I'm trying to show you something. Just got to my mind now. So 20 root 6 over 4 root 2. Let's try to rationalize this. So again, root 2 shouldn't be at that denominator. Root 2 shouldn't be there. That makes it irrational. So we now try to make it rational, that is, make it make sense by eliminating that 2 at the bottom. And in a bid to eliminate the 2 at the bottom, what should we use to multiply the top and the bottom? What should we use to multiply the top and the bottom? A, let's use root 6. B, let's use root 2. A, let's use root 6. B, let's use root 2. So let's hear from you guys. Who are we starting with? Uyosa, A or B? A or B? What should we use to rationalize?
A.
A says, let's use root 6 to rationalize. Okay. Who else? Golden. A or B? A is root 6, rationalize using root 6. B, rationalize using root 2. Which is your choice? Golden.
B.
B. Okay. Uyosa, A. Golden, B. Christine. Okay, no, Matilda. Matilda.
Yes, sir.
A. Let's use root 6 to rationalize, right?
Yes, sir.
Okay. Christine. A or B?
B.
B. We have 2B. We have 2A. Uyosa and Golden. No, Uyosa and Matilda. Uyosa and Matilda said A. Golden and Christine said B. Lucas, what about you?
B.
B. We have 3B and 2A. Are there other people in the class? Because I can see I can see are there people in the class that I can see? I don't think so, because these are the only persons I can see in the class. Okay. All right. So that's by the way. Winner. She's been off and on. All right. Let's just continue. So Uyosa and Matilda are wrong. Uyosa, why do you think we should use root 6 to rationalize? Look at it. Why do you think we should use root 6? Uyosa, why do you think we should use root 6? Why do you think it is root 6 that we should use to rationalize that? Okay, not responsive. Let's ask his partner, Matilda. Matilda said root 6 as well. So Matilda, why should we use root 6 to rationalize? Matilda, oh, none of them are responsive. Lucas,
Yes.
can you please explain why it is wrong for us to use root 6 to make that rationalize?
Well, you need to use the denominator to times both the up and the down.
Okay, so it is the denominator that we use to multiply the top and the down. Christine chose the same answer. So Christine, would you explain why you chose to use the root 2 to rationalize? Why?
Sir, I thought you said which one we prefer.
You thought I said which one what?
We prefer to use.
No, you can't prefer to use. There's a certain sort that you must use. You can't prefer to use. When you're rationalizing, there's a certain sort that you can use, and it is that sort that is at the bottom. Do you understand?
Yes, sir.
Okay, so Christine, can you explain why you chose root 2? Why you think root 2 is what we should use to rationalize that, to multiply?
To 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 gain a square root for the denominator.
That's not a proper answer. Why did you chose to use root 2 in rationalizing, right? To multiply the top and the bottom, the numerator and the denominator. You chose to use root 2. Is that correct?
Yes, sir.
Okay, so now I am asking, why did you choose to use root 2 in multiplying the numerator and denominator?
To combine the two radicals together.
Uh, Still not the proper answer, but then that's fine. Lucas already gave us the answer, but I just needed someone to put it in a more organized way. But he actually gave the answer. So the reason why we are using root 2 to multiply the top and the bottom is because it is root 2 that we are trying to eliminate. Root 2 is the one at the denominator, not root 6. If you had those ones at the numerator, we have no problems with them. They are okay. But like I said, when you now have a root at the bottom, at the denominator, it is irrational, and you have to look for a way to eliminate that root at the bottom. Now imagine you're trying to eliminate the root at the bottom, which is root 2, and you're using something else to multiply the top and the bottom. So that doesn't make sense. The reason why we are using root 2 to multiply the top and the bottom is because it is root 2 that we are trying to eliminate. That is why we use root 2, not root 6, because we are not trying to eliminate root 6. It is root 2 that is at the bottom, which is irrational. It is not proper to have a root at the bottom of the denominator. So trying to remove that root at the bottom is what you mean by rationalization, rationalizing. Do you guys understand? Okay, so that is why you're using the root at the bottom. Melody, you're welcome. Took it long enough. Okay, so back to this. We're using root 2 because it is root 2 that we are seeking to eliminate. So if we continue here, we'll have 20 root 6 over 4 root 2 times, now multiplying, times root 2 over root 2. So root 2 is what we're using to multiply. 20 root 6 over 4 root 2 times root 2 over root 2. And of course, when we multiply this, we have the 20 multiplying the back there. That's, we assume there's a 1 there. So 20 times that one, 20. Then root 6 times root 2 is us root 12. So at the top, we have 20 root 12. Then coming to the bottom, 4 root 2 times root 2. 4 root 2 times root 2 at the bottom. That gives us 4 root 4. 4 root 2 times root 2 gives us 4 root 4. Then again, something else has to be done. Look at that top. At the top, we have 20 root 12. Root 12 is a number that can still be broken down. If you see that root 12, it is a number that can still be broken down. So you can't leave it that way. and this then becomes 20. You break down 12 to be 4 times 3, because there's still a perfect square inside 12. That's 4. So 4 times 3. If you leave it as 12, you get you won't get the full mark. You fail the answer, but you can get the other allocated scores for your working, but you won't get the full answer if you have to follow your marking scheme. So that 12 has to be broken down to a 4 times 3 because there's still a perfect number 4 there. Then at the bottom, all over, the square root of 4 at the bottom is 2. So 4 times 2, that gives 8. 4 times root 4. Root 4 gives you 2. So 4 times 2, that is 8. Then proceeding, this is your root 4 times root 3. That would be, if you want to separate them, that would be 20 times root 4 times root 3 all over 8. 20 times root 4 times root 3, this here, 20 times root 4 times root 3 all over 8. And we already do know that the square root of 4 is 2. So that's 20 times 2 times root 3 is all over 8. 20 times 2 is 40. 20 times 2 is 40. 40 times root 3 is 40 root 3. So at the top we have 40 root 3 because 20 times 2 is 40. Then times root 3, that's 40 root 3. Then all over 8, you have 8 at the bottom there. Now this 8 and that 40 can actually divide themselves because we do not have because they are not carrying roots, so they're both like divisible. You can divide them, but you can't use an ordinary number, a whole number, to divide a number that is inside the square root. But for this 40 and 8, they are both outside, like they're not within a root, so you can actually divide. And then you have 40 divided by 8, that would be 5. Then the final result should be 5 root 3. So this here would be the answer, 5 root 3. When 40 is divided by 8, you have 5, then root 3 there. Do you guys understand this? Okay, Melody, okay. Uyosa, Lucas, what about you? Godin, yeah, I see you. Winner, do you understand? Christine, I didn't say thumbs up. Do you understand? Or probably I wasn't looking. Okay, maybe I wasn't looking. All right, Melody, you raised your hand. You have a question. What is it?
Sir, can we just like divide it straight up without using the root 2?
Without using the,
Root 2.
are you talking, which question are you referring to?
This is that question.
This last question.
Yes.
Okay. All right. Yeah, you can actually do that. I was just showing you what to do properly, like when you cannot divide. Otherwise, you can actually say 20 root 6 over 4 root 2. You can actually decide to say that 20 root 6 over 4 root 2. Can actually decide to say these roots 2 can divide root 6 and you have a balance of root 3 there. That root 2 can divide root 6, you have a balance of root 3. And this 4 can divide 20, you have a balance of 5. And you have 5 root 3. So you can actually do that, but most of the time, you will never be given a question that is just straightforward like that. So what I was doing is to show you the normal way of doing it in cases where you cannot divide like this is what you do. So do you understand?
Yes, sir.
Okay, so this is just a coincidence that you can divide it out directly. So what happens when it now happens to be maybe, let's say, 20 root 3 over, let's say, 3 root 2. So you can see this question now. You can't do that. Look at them. Look at the both of them here. Now, this question, I'll circle it in, let's circle it in red. This question circled in red now. You can't do what you just did at the top here because none is divisible. You can't use root 2 to divide root 6. You can't use the 3 outside to divide 20. So you have no choice than to do what you just did here. So that's just it. This is all you do when you're rationalizing. Use the denominator, the times the top and the bottom. If coincidentally it is a cheap question that you can do directly, that's fine. But make sure only a root divides a root. That is if it's divisible. Only a root can divide a root. Don't use a whole number to divide something that is inside a root. So it's not proper, it's not correct. If you look at this one here, you see that I used the root 2 to divide root 6, and what remained was root 3. Yeah, but when it got to dividing the 20 and the 4 outside, I didn't use the 4 to touch any of the number inside the root. So the 4 and the 20 can divide because they are whole numbers, they're outside multipliers. So it's just how it is. Then I think we can proceed. There is one last part, which is the conjugate of sorts, conjugate sorts. So let's quickly look at that, and then we can say, okay, we're done with sorts. There are sorts that lead to equations too. There are sortic equations, that's equations involving sorts. So, but that's mostly in JAMB questions. And then it's also in, is anyone here writing, is everyone here writing like anyone sitting for GCSE? Is anyone writing GCSE or just WAEC? Okay, Christine, you're writing GCSE. Matt, who is writing? Okay, all of you are writing WAEC. Please unmute your mic, let me know, because so that I'll know if to deal with that. Because I know there are certain exams that, okay, WAEC, everyone WAEC. All right. Christine, WAEC or GCSE?
GCSE, sir.
Okay, so you would need that equations involving sorts. You need that. That's why I was asking you guys, because I know it's not so common. It's common in JAMB, but you've already written JAMB. Then it's common in GCSE, but for WAEC, and most of the time it's not there. So I think we'll have to do it for everyone though. We'll just see how it goes. Today's time won't be enough for that. That means in the next class, we'll quickly run through it, probably with 20 minutes before we go to the next topic. Because, okay, so sorts, what was I saying? Conjugate sorts here. Conjugate sorts. Christine, which exam body, under which exam body is your GCSE?
Edexcel.
Okay, Edexcel. All right. The patterns of questions are the same with AQA. All right. So we're looking at conjugate sorts now. Conjugate sorts. Just like this rationalization of sorts we just did now, there is also rationalizing sorts that are in the form of expression. Let's go back to these ones we've done. If we look at these ones we've done from the rationalization of sorts, you see that at the denominator, what we have is a product 3 root 5. The next one, we had example 2, we had 20 root 6 over 4 root 2. That's the next. Then, okay, there is no other one. Now, in conjugate sorts, you still have a sort at the denominator, but only this time it is given as an expression, something like this. 2 plus, let's say, root 3, or let's just say 5 over 2 plus root 3. So now look at this question, 5 over 2 plus root 3. So you can see that root 3, we have a root at the denominator, which makes it irrational already. So it's not proper that the root is there. But in this case, you see that that denominator is some sort of, you're adding a whole number and a surd. If these were letters, you would say it's an expression. Juxtapose this and these other ones you've looked at. Look at this. At the denominator, we're having 2 plus root 3. Now compare it with these other ones we've looked at. Look at example 2. It is not 4 plus root 2, it is 4 root 2. It's a product. They are together. Look at example 1. At the bottom, it's not 3 plus root 5 or 3 minus root 5. It is 3 root 5. So you see that they are different. Example 1, example 2, they are different from this type now that says 5 over 2 plus root 3. So what do you do when you have this type? That is what brings us to the conjugate of sorts. So now you rationalize again, but this time you will not say you're multiplying the top and the bottom by root 3. That is when I did when it was something like this. I did when it was something like 5 over 2 root 3. Yeah, that's when you can rationalize by multiplying the top and the bottom with root 3. But in this case, it is not. There is a plus there, or if it's a minus. So what you do is rationalizing by multiplying with the conjugates. This now brings us to what a conjugate is. The conjugate of that, remember, it is a denominator. You have no business with the numerator. It is a denominator that you have the problems with. So that's where you get the number, whatever you're using to multiply, that's where you should get it from, not the top. The conjugate of this denominator, if it is 2 plus root 3, your conjugate here will be 2 minus root 3. This is the conjugate. If it is 2 minus root 3, the conjugate is 2 plus root 3. If it is 2 plus root 3, the conjugate is 2 minus root 3. Look at this. Another one. Let's say we have root 5 minus root 2. Here will be root 5 plus root 2. This is the conjugate. So if you have root 5 minus root 2, your conjugate is root 5 plus root 2. If you have root 5 plus root 2, the conjugate is root 5 minus root 2. So the conjugate simply means that change the sign, whatever sign you have there, just change the sign, that's all. The same numbers, the same source and everything, but change the sign of the denominator. When you change the sign, then use that result you have to multiply both the top and the bottom. Now let's come back to this 5 over 2 plus root 3. 5 over 2 plus root 3. So to rationalize this, we have to multiply by the conjugate, the top and the bottom. That's the numerator and the denominator. You multiply with the conjugate. That means conjugate of the denominator, do not forget. That means we're multiplying with 2 minus root 3 over 2 minus root 3. Because the conjugate of that denominator is 2 minus root 3. We have 2 plus root 3. So the conjugate will be 2 minus root 3. And it is that conjugate we will use to multiply the top and the bottom. Do you guys understand? What about the others? Melody, do you understand? Lucas, do you understand? Christine, okay. Lucas, okay.
Sir, my network
Okay, my
is bad.
you say?
Sir, my network
Melody,
is
come.
bad.
Oh, okay. Your network is bad. Well, just try to follow though. So we have this, we're trying to rationalize now by the conjugate. Remember we said the actual question was 5 over 2 plus root 3. And when we were rationalizing with the conjugates, we'll have to change that 2 plus root 3 to 2 minus root 3 at the denominator. That's why we are now multiplying the top and the bottom by 2 minus root 3. So bringing these together, trying to expand, we'll have something like this is 5 bracket 2 minus root 3, then over the other one, we have 2 plus root 3 bracket 2 minus root 3 because we have to multiply. At the top, we have times 5 times 2 minus root 3. That's 5 brackets 2 minus root 3. Then at the bottom, we have 2 plus root 3 times 2 minus root 3. That's 2 plus root 3 in one bracket, multiplying 2 minus root 3 in the other bracket. Now, expanding the bracket at the top, we have 5 times 2 to be 10 minus 5 times root 3 to be 5 root 3. At the top, we have 5 times 2 to be 10 minus 5 times root 3 to be 5 root 3. Then over at the bottom now, if we want to multiply, you know how we arranged it the other time. We said 2, we multiply the second bracket, then plus root 3 also has to do the same thing, multiplying the second bracket. So 2 multiplying at the bottom, 2 in the first bracket, multiplying the second bracket, then plus root 3 also multiplying the second bracket. But if you know how to multiply it directly, then you can do that. You don't have to do this. I'm just writing it out this way for people that might understand it better. So at the top, we still have 10 minus 5 root 3 because we can't do anything there. Please don't subtract this and say 10 minus 5 root 3 is 5 root 3. They are not like terms. That 10 doesn't have a root 3. So you cannot subtract the 10 and the minus 5 root 3. Do you guys understand? At the top, 10 minus 5 root 3, you cannot subtract them. Do you understand? Okay, just follow up with what we're doing. You just follow up. We've not done so much yet. So back to this. So I have 10 minus 5 root 3. Melody. Was that Melody? Melody, was that you that said your network was bad?
No, Matilda.
No.
Okay, all
Okay,
right.
yes.
Where did you what was the last thing you understood?
5/2 plus root 3 equals to 5/2 minus root 3.
Okay, that's how to get the conjugate. Well, you know how to get the conjugate, right?
Yes, sir, please leave it like this. I'm copying the notes, please.
Okay. All right. So coming back at the bottom, please, who can expand this bottom for us? Who can expand the denominator for us? Someone please volunteer to expand the denominator. Who can do this? 2 bracket 2 minus root 3 plus root 3 bracket 2 minus root 3. Who will expand this? Matilda, do you want to try?
No, sir, I don't understand.
Okay, it was you that said your network has been bad. Who else? Melody said the same thing. Lucas, not responsive. Christine,
Yes, sir.
do you want to expand the denominator for us here? Two
4
bracket 2 minus 3. All right, so go on.
4 minus 2 root 3
minus 2 root 3.
plus
The other bracket. Okay, don't worry. Don't worry. Let someone else. Don't worry. So that's the expansion of the first bracket. 2 times 2 is 4 minus 2 times root 3, 2 root 3. So the second bracket, who will take that? Melody. The second bracket, expand the second bracket. It has nothing to do with conjugate or whatever. It's what we've done before, expansion of brackets. So look at the second bracket and expand it. Root 3
Plus
times 2
2
minus
root
root
3
3 plus 2 root 3.
minus root 9.
Okay, minus root 9. Okay, so going forward, we still have here 10 minus 5 root 3 over, you see this, we have 4. Then you see minus 2 root 3 plus 2 root 3. This is just like saying minus 2s plus 2s. So that gives 0. Minus 2 root 3 plus 2 root 3. So it's just like minus 2s. Remember, they're like terms. Minus 2 root 3 plus 2 root 3. They both possess 2 root 3. They both possess root 3 rather. So it's like if root 3 stands for s. So this is like saying minus 2s plus 2s. And of course, that would be 0. So there we have 4 minus the square root of 9 is 3. Square root of 9 is 3. The final answer would be 10 minus 5 root 3. 4 minus 3 is 1, so that's needless to write. So this is the answer, 10 minus 5 root 3. 10 minus 5 root 3. So this is how you rationalize sorts and that has are in this form, in the conjugate form this way, 5/2 plus root 3. Please take note, you only use the conjugate when you're having it like some sort of an expression, 2 plus root 3, 2 minus root 3, whatever it is, but at the bottom you're now having minus between two different terms. that is when you use the conjugate. And how to get the conjugate is simply using that denominator, changing whatever sign is there to the opposite. Like 2 plus root 3, the conjugate is 2 minus root 3. And the conjugate of 2 minus root 3 is 2 plus root 3. So you're simply changing the sign. Root 5 minus root 2, the conjugate is root 5 plus root 2. The conjugate of root 5 plus root 2 is root 5 minus root 2. So simply look for the conjugate of the denominator, use it to times the top and bottom. So you do this differently, unlike this, the way you did this one, that there is no plus or minus between the terms. So you do this one differently, and then here, use the conjugate to multiply the top and the bottom, expand the brackets, and then you see what you have. So we are taking one general question because it's just 5 minutes to the end of the class. So we're taking one general question. Each person in the class will take one step, not one person solving it completely. Each person will take one step. So let's just say the question is 2 plus, no, 3 root 2 plus 2 root 5 over root 2 minus root 5. Okay, so let's deal with this. It's a general work. We'll be doing it together. Let's deal with this. 3 root 2 plus 2 root 5 over root 2 minus root 5. So first question goes to I'll just follow what I see here, the way it's arranged here. So first question goes to Matilda. Matilda, please unmute your mic. What is the conjugate we should use to multiply the top and the bottom here?
It would be root 2 plus root 5 to multiply the top and
Okay,
the down.
okay. So since we're dealing with the bottom, it's the bottom we're dealing with. So we have to go and get the conjugate from the bottom. It has nothing to do with the top. Getting the conjugate from the bottom, we'll now say the conjugate of that bottom is root 2 plus root 5. That's because what we have there is root 2 minus root 5. So we'll say root 2 plus root 5, use it to times the top and bottom. And then when we do this, we can now arrange this result we have to be something like this. In the brackets, 3 root 2 plus 2 root 5 multiplying root 2 plus root 5 over root 2 minus root 2 minus root 5 multiplying root 2 plus root 5. So now I have brought them together, the top multiplying the top times the bottom multiplying the bottom as well. So now someone take the the expansion of the top, the numerator. Who will take the expansion of the numerator? Next person here is a Fosa. That's the next name I see here. But I do not know if Fosa has been active in the class because I'm just saying the name. I saw it about 5 minutes ago though, but then I do not know. So Fosa, do you think you can expand that the numerator for us? Golden, you had a question?
Yes.
Okay. So what was your question?
Huh?
What's the question?
What the fuck?
I thought I saw you raise your hand.
No. I didn't raise my hand. I didn't raise my hand.
Oh, okay. All right. So, Efosa, sorry, back to you. Would you want to expand that, the numerator for us? Okay, not responsive. Uyosa. Uyosa. Oh, not responsive as
No,
well.
sir, just join
Lucas.
the class. I don't
Oh,
understand
all right. Okay.
So,
anything.
so you called me.
All right. Yes, Uyosa, I was asking if you can expand the numerator for us. All right. So, do you know what happened? Should we take the completion of that work as an assignment? Let's vote. You put up your. Okay. Should we take the completion of the work as an assignment? Please put up your hand if you agree. Okay.
Sir,
Golden
sir,
disagrees.
sir, sir, can I see my answer?
Yes. We wouldn't know the final answer. I'll have to work with it, like solve it so that we get to the results together. When you say the final answer, we wouldn't know if it's correct until we have to
I
work
only
it. So I am
expanded the
asking,
numerator.
you said?
I only expanded the numerator.
Okay, so it's all right. So tell us the results you got.
I got 16 plus 5 root 10.
Tell us the expansion bit by bit. When you did 3 root 2, you did 3 root 2 multiplying this, and then plus 2 root 5
Yes.
multiplying 2 plus root 5. This is what you did.
Wait.
At the top, 3 root 2 multiplying root 2 plus root 5, then
Yes.
plus 2 root 5 multiplying root 2 plus root 5.
Yes.
Okay, so we'll come to that. I was saying we should take it as an assignment, but most people were disagreed, so we'll just try to finish it. Otherwise, it's past time. So at the bottom, root 2 is multiplying root 2 plus root 5, then minus root 5 is also multiplying root 2 plus root 5. So that's what we have at the bottom. Root 2 is multiplying root 2 plus root 5. Then minus root 5 is also multiplying root 2 plus root 5. So if you expand that bracket, the numerator, you should have 3 root 4 plus 3 root 10 plus 2 root 10 plus 2 root 25. So was this what you got at the numerator, Yosa?
Sir?
Look at the results there. Was it what you got? All right. So we'll proceed from here.
Sir, should I explain how
Third,
I got it?
I'm coming. I'm trying to quickly finish this because of the time. So 3 root 4, that's the square root of 4 is 2. So 3 times 2 is 6. Then plus 3 root 10 plus 2 root 10, that is plus 5 root 10, then plus 2 times the square root of 25 is 5. So 2 times 5 is going in there, and then we just we use our guts. So at the bottom, we have square root of 4 is 2. Then plus root 10 minus root 10, that's goes. Root 10 plus root 10 minus root 10, that would be 0. Then we have minus square root of 25 is 5. So user, I think your numerator is correct. Go have 6 plus 10 to be 16 plus
Yes. Plus 5 to 10.
16 plus 5 root 10.
Yes.
Yes, at the top. Then at the bottom, we have 2 minus 5 minus 3. So this is the results we get when we get this question. So you can see that the root is no longer at the denominator. So this is the result we get. Does everyone understand this? Okay, Christine. Who else? This person that doesn't understand, I don't seem to. Christine, is that you? Efosa. Okay. Efosa. Efosa, did you say you do not understand?
Yes, I don't understand how
Has your network been good?
you got it. I understand the
You don't understand what? Your network is
less
glitchy. I
explanation,
can't hear you. It's breaking.
but I
It's
don't
breaking.
understand
I couldn't hear what you said.
how you.
All right, it's no problem. We'll take a quick look. Don't worry. We'll take a quick look at this part the next time you have the class before we go to the next whatever I'll have to do. We'll take
I
a,
just joined the class from the
we'll take a quick look at this particular part the next time we have a class because the time is up already and I'm just trying to hurry. But then if let me just know how many persons first. Let me know how many persons has problems with challenges with this. Just give the reaction on your. Just give the reaction. Okay, Golden is okay. Lucas is okay. Please give the reaction so that I'll know. And then from the next class, okay. Golden, Christine is okay. Golden, all right. Golden, do not worry. From the next class, we'll look at this. Golden is confusing me. You're crying, you're giving thumbs up, you're giving thumbs. Golden, all right, do not worry. From the next time we'll have a class, we'll take a quick look at this again. And then before we continue. So until next time, you guys take care of yourself. Bye.